Hello and welcome. Tonight, we'll be exploring what would happen if Voyager 1 continued drifting for another billion years. Somewhere far beyond the familiar planets, a small human-made spacecraft is still moving through the darkness. It carries no crew, no engine that needs to burn continuously, and no destination that it must urgently reach. It simply travels onward, crossing distances so immense that ordinary ideas of time and space begin to lose their meaning. A billion years from now, the Earth could look profoundly different. The sun will have changed, the continents will have shifted, the stars around our solar system will no longer occupy the same places in the sky. And yet, if Voyager avoids a major collision, that little spacecraft could still be drifting through the Milky Way, carrying with it a tiny physical memory of the world that launched it. So, find a comfortable place to rest, and let's gently begin our journey into one of the most fascinating questions in science. To understand where Voyager might be going, we first have to remember where it came from. Voyager 1 began its journey in September of 1977. At the time, nobody was sending it toward a billion-year adventure. Its original purpose was much more familiar. It was built to explore the giant planets of our solar system, particularly Jupiter and Saturn. And what a journey that was! Voyager traveled outward from the Sun and eventually past Jupiter, returning observations that transformed our view of this enormous world. It then continued towards Saturn, studying its atmosphere, rings, moons, and the strange collection of worlds gathered around it. The spacecraft was doing exactly what it had been designed to do: explore, observe, send information home, and then something rather remarkable happened. The planetary mission ended, but Voyager did not. There was no reason for the spacecraft to turn around. There was no road waiting behind it. Space does not have a finish line at the edge of a mission. So Voyager simply continued outward. Its path carried it farther and farther from the Sun, away from the warm, crowded region of planets, moons, asteroids, and familiar worlds. Eventually, it crossed a distant boundary known as the heliopause. You can think of this boundary as the far outer edge of the Sun's great sphere of influence. The Sun constantly sends a thin flow of charged particles outward into space, like an invisible breath extending far beyond the planets. At the heliopause, that outward influence meets the much thinner environment between the stars. Voyager had entered interstellar space. For humanity, this was an extraordinary moment. A machine built on one small planet had crossed into the space between stars. And yet Voyager did not suddenly find itself surrounded by a crowded cosmic highway. Interstellar space is overwhelmingly empty. There are stars, clouds of gas, microscopic grains of dust, and countless particles passing through the darkness. But the distances between substantial objects are enormous. This emptiness is one of the reasons Voyager can keep traveling for such an astonishing length of time. You might imagine that a spacecraft needs an engine constantly pushing it forward, much like a car needs fuel to keep moving down a road. But space is different. Once Voyager was given its outward velocity, there was almost nothing around it capable of slowing it down significantly. There is no atmosphere creating strong drag. There is no ocean resisting its motion. There is no road surface rubbing against its wheels. The spacecraft can simply coast. Its electrical power is another matter. Voyager's onboard power system has been gradually weakening, and its scientific instruments have been switched off over time to conserve the remaining energy. Eventually, the spacecraft will become completely silent. But silence is not the same thing as stopping. The machine may lose its ability to speak to Earth long before it loses its ability to move through space. And this is where the story becomes particularly strange. Voyager is traveling at roughly 17 kilometers every second. That sounds extraordinarily fast. By everyday standards, it is. But the universe has an unusual way of making fast things seem slow. Imagine walking across your neighborhood. Then imagine driving across an entire country. Then imagine crossing the Earth. Each step upward makes the previous distance seem smaller. Now imagine the distance between stars. Suddenly, even a spacecraft moving tens of thousands of kilometers each hour seems almost motionless. This is why Voyager's journey cannot really be measured in ordinary human terms. Not years, not decades, not even centuries. The meaningful timescales begin to stretch into thousands, millions, and eventually billions of years. And the farther Voyager travels, the more interesting the story becomes, because it is not moving through a frozen universe. The galaxy itself is moving, the stars are moving, the sun is moving, the solar system is moving. Even the destination we might imagine for Voyager is part of a vast cosmic landscape that never remains perfectly still. It is almost like throwing a small paper boat into a river and then discovering that the river itself is flowing through another river, while the landscape around both rivers is slowly changing. Voyager is not traveling across a fixed map. It is traveling through a moving galaxy. Already, we can begin to see why a billion-year journey would be so different from an ordinary space mission. The spacecraft would not simply become farther away. Everything around it would gradually become different. The stars would change their positions. Familiar constellations would slowly lose their familiar shapes. The solar system would move through another part of the Milky Way. And far behind Voyager, the planet that built it would also be changing. For now, though, Voyager is still only at the beginning of this enormous journey. In roughly 40,000 years, it is expected to pass relatively close to a star called Gliese 445. In astronomical language, close is a very strange word. Voyager would still remain more than a light year away. For comparison, that is a distance so vast that even light, moving faster than anything else we know, needs an entire year to cross it. So Voyager's encounter with Gliese 445 would not be a visit. It would be more like a distant passing in the darkness. And after that encounter, the spacecraft would continue onward. No celebration, no destination reached, no signal announcing that the journey was complete. Just the quiet continuation of motion. A small machine, launched in 1977, slowly leaving its century behind. And as the years become thousands of years, and the thousands eventually become millions, something even more remarkable begins to happen. Voyager will not be the only thing changing. The sky itself will begin to forget the shapes we know today, and that is where our sense of the journey begins to stretch far beyond the human lifetime. There is something almost counterintuitive about Voyager's journey. The spacecraft is moving incredibly quickly by human standards, yet when we place that speed against the scale of the galaxy, it begins to look almost gentle. Voyager travels at roughly 17 kilometers every second. You do not need to picture the number itself. Instead, imagine covering the length of a large city in only a few seconds. Imagine continuing at that pace without stopping, hour after hour, year after year. In a single day, Voyager travels more than 1 million kilometers. In a year, the distance becomes hundreds of millions of kilometers. It sounds enormous, and it is. But space has a curious way of turning enormous distances into small ones. The Moon is relatively close to Earth. Light takes only a little more than a second to travel between them. Yet, even the Moon's distance reminds us that space is already much larger than our everyday surroundings. Then comes the Sun. The light that warms your face on a quiet morning has traveled for about 8 minutes before reaching Earth. The planets spread out even farther. Beyond them are the outer regions of the solar system, where the Sun's influence becomes increasingly faint. And then, eventually, there are the stars. The nearest stars are not merely farther away than another city, another country, or another continent. They are separated from us by distances that are difficult to translate into ordinary experience. This is why astronomers use the light year. Despite its name, a light year is not a measure of time. It is a measure of distance, the the distance light travels in 1 year. Light moves so quickly that it can cross the Earth many times in a fraction of a second. Yet even light needs an entire year to cross 1 light year, and Voyager is moving far more slowly than light. That difference is one of the quiet mysteries at the heart of this story. Voyager does not need to stop, but it also does not have anywhere nearby to arrive. Imagine standing beside a perfectly calm road that stretches beyond the horizon. You release a small vehicle onto it, and the vehicle continues moving at a steady speed. If the road were only a few kilometers long, you might expect it to reach the other side quickly. But now imagine that the road stretches farther than you can see, then farther than an entire country, then farther than the Earth, and finally, imagine that the road crosses the spaces between stars. At that scale, the vehicle could keep moving for thousands of years and still be traveling through what feels like the beginning of its journey. That is Voyager. Its speed is real. Its motion is real. The distances are simply enormous. And there is another reason Voyager can continue drifting for such a long time. There is very little in interstellar space to slow it down. On Earth, almost everything around you resists motion. If you slide a book across a table, the book gradually stops because the surface beneath it pushes against it. If you ride a bicycle and stop pedaling, air resistance and friction slowly take your speed away. If you throw a ball through the atmosphere, the air pushes back. Space is different. Far beyond the planets, there is an extraordinarily thin mixture of particles and dust. It is not a perfect vacuum, but it is empty enough that ordinary friction becomes almost irrelevant over the enormous distances Voyager will travel. So Voyager does not need to keep its engines running. It is not constantly pushing itself forward. It is more like a stone that has been thrown into an immense, almost frictionless darkness. Once moving, it can continue. There is an important distinction here. Voyager's electrical power will not last forever. Its radioisotope power system gradually produces less electricity as the radioactive material inside it naturally loses energy. Because of this, engineers have been turning instruments and systems off over the years, carefully managing the remaining power. Eventually, there will be too little electricity to operate the spacecraft. The instruments will be silent, the transmitter will fall silent, the antenna will no longer send its faint messages toward Earth. But none of that means Voyager suddenly stops. Its power system is not what keeps it moving through space. Electricity allows Voyager to think, measure, remember, and communicate. Motion is something different. The spacecraft already has its velocity, and in the thin darkness between the stars, there is very little to take that velocity away. So there may come a strange moment in Voyager's distant future when the machine is no longer a spacecraft in the ordinary sense. It will no longer be listening. It will no longer be measuring the magnetic environment around it. It will no longer be turning its antenna toward Earth. It will simply be an object moving through space. And perhaps that is one of the strangest things about its journey. A spacecraft can stop functioning without stopping traveling. Its electronics may become silent while its path continues. Its human operators may be long gone. The voices that once waited for its signals may belong to history. But the spacecraft itself can continue. There is no cosmic clock that rings to announce the end of a mission. There is only motion, and time, and distance. At today's speed, Voyager would travel roughly 17 light-years in 100,000 years. If we simply extend its present motion into the future, that number may sound enormous. But the Milky Way is roughly 100,000 light-years across. So even after 100,000 years, Voyager would have crossed only a tiny part of the galaxy. And this is where the scale of the journey begins to become almost dreamlike. 100,000 years is longer than the entire span of recorded human civilization. Cities would rise and disappear. Languages would change, coastlines would move, generations would follow generations, until no living memory remained of the world that launched Voyager. Yet the spacecraft would still be moving, and there would be another traveler alongside it, although much farther away, the stars themselves. They do not stay fixed in place. The sun is moving around the center of the Milky Way. Other stars are moving along their own paths. The galaxy is not a frozen picture. It is a vast, slowly flowing system. So when Voyager crosses the distance between stars, it is not passing through a static landscape. The landscape is moving too. A star that appears to be in one place today may be somewhere else tens of thousands of years from now. The constellations that seem permanent from your window are only temporary patterns created by stars at different distances, all moving through space at their own speeds. Given enough time, even the night sky will begin to forget itself, and Voyager will continue through that changing darkness, not because it has infinite energy, not because its engines will run forever, but because, once it was sent outward, the universe gave it something very simple: room to keep going. 40,000 years is difficult to imagine. You can think about a year because you have lived through years. You can think about 10 years because you can remember how much your life can change within a decade. 100 years already feels distant. 1,000 years belongs to another world entirely. But 40,000 years reaches back to a time when human beings were living very different lives, long before modern cities, modern nations, or written history as we know it. And somewhere in that unimaginably distant future, Voyager 1 may still be moving through the darkness. By then, the spacecraft will have been traveling for longer than almost the entire story of human civilization. Its radio transmissions will have fallen silent. Its instruments will no longer be collecting scientific measurements. There will be no mission control waiting for another signal. There may not even be a human civilization on Earth that remembers exactly what Voyager was. But the spacecraft itself can continue, and during this enormous stretch of time, Voyager is expected to pass relatively close to a star known as Gliese 445. The word close needs a little care here. In everyday life, if someone tells you that two objects are close, you probably imagine being able to walk from one to the other. In astronomy, close can mean something completely different. Voyager is expected to pass more than a light year away from Gliese 445. That is an enormous distance. Light itself would need more than a year to cross it. So Voyager will not arrive at Gliese 445. It will not orbit the star. It will not land on a planet. It will simply pass through the broad neighborhood of that distant star. And even this gentle encounter tells us something important about interstellar space. The stars are not packed together like lamps in a city. They are separated by vast regions of darkness. Imagine looking across a huge field at night and seeing a handful of tiny lights scattered across it. Now make the field unimaginably larger. Move the lights even farther apart. Then imagine that every light is also moving. That is closer to the reality Voyager experiences. The spacecraft can travel for tens of thousands of years and still encounter very few stars at anything we would call a close distance. This is also why the possibility of Voyager colliding with a star or planet is extraordinarily small. Space may contain countless worlds, but the space between those worlds is enormous. A spacecraft does not need to weave between planets like a car avoiding traffic. There is almost no traffic. There is mostly emptiness. And yet, even while the space around Voyager appears almost unchanged, the galaxy itself is slowly rearranging. The stars are moving, the sun is moving, the planets are moving with the sun, and Voyager is moving independently through this enormous gravitational landscape. From Earth, the night sky can feel strangely permanent. You can look upward and recognize familiar patterns. Perhaps you know Orion. Perhaps you recognize the Big Dipper. Perhaps you have never learned the names of the stars at all, but you can still look at the sky and feel that the same stars have always been there. In a human lifetime, they seem almost fixed. But they are not fixed. They are travelers too. They simply move so slowly across our sky that the change is difficult to notice. Give them tens of thousands of years, and the picture becomes different. The stars that make up today's constellations will gradually shift relative to one another. The familiar patterns will stretch. Some stars will drift closer together in our sky. Others will separate. New stars will become prominent. Old patterns will slowly disappear. The night sky of the distant future will not look like the night sky above you tonight, and Voyager will pass through that changing sky. This gives us an unusual way of thinking about the spacecraft. We often imagine Voyager as the thing that is traveling while the universe remains still around it. But that is not really what is happening. Voyager is traveling through a universe that is traveling too. The Milky Way is not a giant picture hanging motionless in space. It is a vast collection of stars, gas, dust, planets, and dark matter, all participating in enormous motions. Some stars orbit the galactic center, some move relative to their neighbors, some are born from clouds of gas. Some eventually die and leave behind remnants. The entire galaxy is alive with movement, although most of that movement happens on timescales far longer than a human lifetime. Voyager simply has the patience to notice. And patience is something that a machine does not need to learn. It does not grow bored. It does not wonder why the journey is taking so long. It does not look at the horizon and ask when it will finally arrive. It just continues. This is one reason the story of Voyager becomes more interesting when we stop thinking about it as a spacecraft on a mission and start thinking about it as an object moving through deep time. The mission has a beginning, the mission has an end, but the journey of the object itself can continue long after both. 40,000 years from now, Voyager's encounter with Gliese 445 will be only a distant passage, and perhaps by then, nobody will be watching. No telescope may be pointed toward it. No human voice may be waiting for a signal. The event could happen in complete cosmic silence. Voyager will simply pass through the broad neighborhood of another star and continue onward. But something else will have changed. Far behind it, the Earth will no longer be the same Earth. Its continents will have shifted. Its ecosystems will have changed. The languages spoken by its inhabitants, if any inhabitants remain, may be completely different from ours. Even the stars that once surrounded the sun in our night sky will have moved. The spacecraft will still carry a small piece of the world that launched it, but that world will be becoming increasingly difficult to recognize. And this is where Voyager's journey takes on another meaning. It is not only traveling away from home, it is gradually traveling away from the era in which home can still be remembered. The farther it goes, the more the familiar universe becomes unfamiliar. And the longer it travels, the more important the simple question becomes. What exactly does it mean for a small object to survive when almost everything around it changes? The answer begins to emerge as Voyager moves beyond tens of thousands of years and into 1,000,000 years, where the galaxy has even more time to reshape itself. 1,000,000 years is a strange kind of distance in time. It is long enough for entire landscapes to disappear and return in different forms. Long enough for mountains to rise, erode, and be replaced. Long enough for countless generations of living creatures to pass across the surface of Earth, each one briefly occupying a small moment before giving way to another. And for Voyager, 1,000,000 years would simply be another stretch of its journey. If we take its present outward speed and extend that motion into the distant future, Voyager could have traveled roughly 170 light-years from the Sun after 1,000,000 years. 170 light-years. It sounds like an enormous achievement, and it is. But there is a quiet surprise hidden inside that number. The Milky Way is roughly 100,000 light-years across. So after 1,000,000 years, Voyager would still have traveled only a small part of the galaxy. This is one of the strange lessons of cosmic distance. A million years can feel almost infinite to a human mind, while remaining only a portion of a journey across the galaxy. By this point, Voyager would also be passing through a very different stellar neighborhood from the one it knows today. The stars around it would not be the same collection of bright points we see from Earth tonight. Some would have moved farther away, others would have drifted closer. Some stars that are familiar to us might no longer appear anywhere near their present positions, and some of the stars that future observers considered important might not have been especially noticeable to us at all. The sky would have changed its arrangement, but the space between those stars would remain extraordinarily empty. Voyager would continue passing through what astronomers call the interstellar medium. The name sounds complicated, but the basic idea is simple. It is the extremely thin material spread through the spaces between stars. There is gas. There is dust. There are tiny particles. There are regions where the material becomes somewhat denser. There are also enormous areas where almost nothing is present. When you look at photographs of colorful nebulae, it can be tempting to imagine them as thick clouds filling space like fog. But from the perspective of a spacecraft moving through them, many of these regions would still be remarkably thin. It would not be like sailing through a storm cloud. It would be more like moving through a huge room in which only a few invisible grains of dust happen to be scattered. Voyager would simply pass through, a tiny object moving through an almost empty environment, and there would be no wind in the ordinary sense, no rain, no road, no surface, only particles separated by enormous distances. Over such a long journey, however, even tiny things can begin to matter. Cosmic radiation would continue passing through the spacecraft. Microscopic particles of dust could occasionally strike its surfaces. Materials would gradually age. The spacecraft was not designed to remain pristine for a million years, and we cannot know exactly what its physical appearance would be after such an immense span of time. Perhaps some surfaces would become weathered. Perhaps certain materials would have degraded. Perhaps tiny impacts would have left marks that no engineer could have predicted in 1977. Time itself would become part of Voyager's environment. There is something almost poetic about that. When Voyager was young, its appearance was determined by engineers. After a million years, its appearance could be determined partly by radiation, dust, temperature, and chance. The machine would slowly become an artifact, shaped by the universe through which it traveled. And by then, its electronics would almost certainly have been silent for an extraordinarily long time. There would be no scientific instruments quietly measuring the surrounding particles, no transmitter sending carefully encoded information back toward Earth, no antenna waiting for another command. The spacecraft could still be physically intact in some form, but its technological life would be long over. This distinction is worth pausing over. When we say that Voyager is traveling, we might imagine that the spacecraft itself is still operating. But eventually, that will no longer be true. Its mission can end. Its electricity can end. Its communication can end. Its ability to gather new information can end. And still, its motion can continue. It becomes almost like an old clock, whose hands have stopped, while the object itself remains on a shelf. Except Voyager has no shelf. Its shelf is the galaxy, and its clock has no need to keep time. It simply moves. Meanwhile, the solar system continues its own enormous journey. The Sun is not sitting still at the center of the galaxy. It orbits the center of the Milky Way, carrying Earth and the other planets along with it. One complete journey around the galactic center takes roughly 230 million years. So in 1 million years, the solar system has moved only a small fraction of that enormous circle. But the important point is that the Sun and Voyager are both traveling through the galaxy. The solar system is moving in one great galactic path. Voyager is moving outward along another. their separation grows, and the galaxy continues turning beneath both stories. It is tempting to imagine Voyager as leaving the solar system behind, like a traveler leaving a town. But there is no stationary road behind it. The solar system itself is moving, the stars are moving, the galaxy is moving. Even the destination Voyager appears to be traveling toward is part of this constant motion. It is a little like trying to throw a ball toward a bird, while both you and the bird are moving, and the entire field beneath you is slowly rotating. The simple direction you see today does not remain simple forever. This is why predictions about Voyager's exact position in the extremely distant future become increasingly uncertain. We can make useful estimates from its present motion. We can understand the broad scale of its journey, but we should not imagine that we can draw a perfectly precise line from Voyager today to a tiny dot 17 or 18,000 light-years away, 1 billion years from now. The galaxy has too much motion, too much gravity, too much time, and perhaps that uncertainty makes the journey even more beautiful. We do not need to know exactly where Voyager will be. We only need to understand that it will probably keep moving, and while it does, the universe around it will continue changing. 1 million years is already long enough to make the night sky unfamiliar, but it is still only a brief opening in the deeper history of the galaxy. Because if we allow the clock to continue turning, Voyager enters a period when stars can be born, evolve, and disappear, while the solar system itself travels hundreds of millions of years around the Milky Way. The spacecraft is no longer simply traveling into the distance, it is traveling into a different version of the galaxy. 100 million years from now, the journey begins to feel almost detached from the world that created it. If we extend Voyager's present outward motion across 100 million years, the spacecraft could have traveled roughly 1,700 light-years from the Sun. It is an almost impossible distance to picture. If you tried to count the kilometers one by one, you would never finish. If you tried to draw the journey on a map of Earth, the map would become meaningless. And yet, compared with the Milky Way itself, even this enormous journey would still represent only a small part of the galaxy. That is one of the recurring surprises of Voyager's story. The numbers keep becoming larger, but the universe keeps becoming larger with them. 100 million years also changes the meaning of the word sky. Today, when you look upward on a clear night, the stars seem to form a familiar arrangement. Some are bright, some are faint, some are gathered into patterns that human beings have recognized for generations. But those patterns are temporary. The stars are moving through the Milky Way, each following its own path through the galaxy. Given enough time, the shapes we know will slowly dissolve. The constellations will stretch and twist. Stars that appear close together tonight may eventually occupy very different positions. Other stars will take their places. The sky above Earth will become something that no human being today could recognize, and Voyager will be traveling beneath a sky like that. Or rather, there may not even be a meaningful beneath by then. The spacecraft will be hundreds or thousands of light-years from the Sun, moving through an environment where the familiar architecture of the solar system has become an almost impossibly distant memory. But the galaxy around Voyager will still contain many of the same basic ingredients: stars, gas, dust, gravity, darkness, and change. Somewhere during those 100 million years, stars will be born from enormous clouds of gas. Other stars will slowly use up the fuel that allows them to shine. Some massive stars may live brief, brilliant lives and end in violent explosions. Other stars will remain quiet for much longer. The galaxy will continually recycle its material. The same basic ingredients can become stars, planets, dust, and eventually new generations of stars again. Voyager will pass through all of this without taking part in it. It will not be caught inside the heart of a star. It will not suddenly be swept along by a cosmic wind. Most of the time, it will simply cross the immense spaces between these objects. This is another reason the journey can continue for so long. There is remarkably little out there. The emptiness of space is difficult to appreciate because photographs of the universe often show us bright, crowded scenes. Nebulae glow with beautiful colors. Galaxies appear filled with millions or billions of stars. But between the objects that make those images beautiful are vast regions of almost nothing. Voyager will spend most of its journey moving through that quiet emptiness. And while Voyager travels outward, the Sun itself is also traveling. The solar system does not remain in one part of the Milky Way. The Sun carries Earth, the planets, and everything else with it as it follows a huge orbit around the center of the galaxy. One complete journey takes roughly 230 million years. So 100 million years is nearly half of one galactic orbit. That means the Sun will have traveled an extraordinary distance through the Milky Way during the same period in which Voyager has been moving outward. This gives us a strange image. Voyager is leaving the solar system, but the solar system itself is also moving. It is as though two travelers are walking away from the same house, each taking a different path, while the landscape around them slowly changes. Eventually, neither traveler would recognize the place where they began, and Earth itself would be changing too. 100 million years is enough time for continents to move enormous distances. Mountains can rise and erode, oceans can open and close, climates can shift, species can appear, evolve, and disappear. The familiar outlines of today's continents would no longer look familiar. Even if life remained abundant, it would almost certainly be very different from the life surrounding us now. The Earth has never been a permanent stage. It has always been changing. We simply live for such a short time that the changes can appear almost invisible. Voyager gives us a way to imagine what those changes look like when the clock is allowed to run much longer. And then there is humanity. This is where science has to become especially careful. We cannot know what human civilization will look like 100 million years from now. We cannot even know whether our species will still exist. Perhaps humanity will remain on Earth. Perhaps descendants of humanity will live on many worlds. Perhaps intelligent life will change so profoundly that the word human would no longer describe it. Or perhaps the civilization that launched Voyager will exist only in the historical record of some distant future species. All of these possibilities are uncertain, but Voyager carries something that makes this uncertainty especially poignant. It carries a physical reminder of a particular moment. 1977, a small blue planet. A civilization beginning to reach beyond its own world. People gathered around computers and radio equipment, waiting for signals from a spacecraft millions of kilometers away. And now that little machine is moving toward a future in which none of those people will be alive. None of their voices will remain in ordinary human memory. The buildings they entered may be gone. The roads they traveled may have disappeared. The political borders of their countries may mean nothing. The languages they spoke may have evolved beyond recognition. But the spacecraft can continue. Perhaps its surfaces will be altered by radiation and tiny particles. Perhaps some parts will eventually break down. Perhaps it will become battered and dark. We cannot know its exact condition after 100 million years. But if even much of its structure remains, Voyager could become something very different from what it was intended to be. Not a scientific instrument, not a communication system, not an active spacecraft. An artifact, a relic moving through the Milky Way. And this is where the story begins to turn, because 100 million years is already enough to transform Earth, reshape the sky, and carry the Sun a substantial distance around the galaxy. But 1 billion years is 10 times longer. At that scale, even the solar system itself begins to enter a profoundly different era. The Sun will be brighter. Earth's long-term climate will be altered. The familiar conditions that support today's biosphere may be very different. And Voyager, still moving outward, will have crossed thousands upon thousands of light years. It will still not have escaped the Milky Way. Instead, it will be somewhere inside this enormous galaxy, carrying a message from a civilization that may have become almost impossible to remember. 1 billion years. It is difficult even to give that phrase the emotional weight it deserves. 1,000 years can separate us from civilizations that feel almost mythical. 1,000,000 years can transform landscapes, species, and entire ecosystems. But 1 billion years belongs to another level of time altogether. It reaches so far beyond individual human lives that the number itself almost stops feeling like a number. And yet, for Voyager, 1 billion years could simply be another portion of its long drift through space. If we take the spacecraft's present outward speed and simply extend that motion across 1 billion years, the resulting distance would be roughly 17,000 to 18,000 light-years from the Sun. That number is astonishing. But there is something even more astonishing about it. Voyager would still be inside the Milky Way. The Milky Way is enormous, stretching roughly 100,000 light-years across. So even after a journey lasting 1 billion years, Voyager would not have crossed the galaxy. It would not have reached some distant edge of the universe. It would not have escaped into a completely different galaxy. It would still be traveling through its original galactic home. This is one of those moments when the scale of the universe quietly overwhelms our imagination. For a human being, 1 billion years is almost beyond comprehension. For the Milky Way, it is a long but not unimaginable chapter in its own history. And there is an important detail hidden inside our calculation. 17,000 to 18,000 light-years is not a promise about Voyager's exact future location. It is what we get when we take its current outward motion and extend it across an enormous amount of time. The real path would be more complicated. Gravity is still present. The stars are moving. Voyager is moving through the gravitational environment of the galaxy, and the galaxy itself is changing. So after 1 billion years, we should imagine a broad region of space rather than a tiny point that we can locate with perfect precision. What we can say with confidence is that Voyager could have traveled an extraordinary distance, and it could still be drifting through the Milky Way. There is another traveler we should think about here, the Sun. It is easy to imagine the Sun as a stationary lighthouse, while Voyager disappears into the darkness. But the Sun is not standing still. The entire solar system is orbiting the center of the Milky Way. One complete galactic journey takes roughly 230 million years. So over 1 billion years, the Sun would have traveled around the galactic center more than 4 times. More than 4 enormous journeys. Earth would have been carried along with it. The planets would have followed. The solar system itself would have crossed a huge distance through the galaxy. And Voyager would have taken a very different path outward. So the spacecraft and its home would both be travelers. They would simply be traveling in different directions. This gives us a beautiful way to think about the meaning of leaving home. Voyager does not leave a stationary Earth behind. Earth is already moving. The Sun is already moving. The galaxy is already moving. Everything is part of a much larger journey. Voyager simply begins a journey that becomes more independent from its birthplace with every passing millennium. And while Voyager travels through the darkness, the Earth itself enters a very different future. The Sun will not remain exactly as it is today. Stars like the Sun slowly become brighter as they age. Over extremely long periods, that gradual increase in brightness can have profound consequences for Earth's climate. The planet receives more energy from its star. The delicate balance that allows today's oceans, atmosphere, and ecosystems to exist can change. The details are complicated, and scientists cannot describe the exact surface of Earth 1 billion years from now with certainty. But one thing is clear: Earth will not simply be a frozen photograph of the planet we know today. Its continents will have moved. Its oceans will have changed. Its atmosphere may be profoundly different, and the living world will have undergone enormous biological transformation. Species will appear, species will disappear. Evolution will continue its patient work. The plants and animals around us today are temporary residents of Earth's long story. Even human civilization, which feels so permanent when viewed from within a human lifetime, occupies only a tiny moment. If humanity survives for another billion years, it may no longer resemble the civilization we recognize today. Perhaps people will live on other planets. Perhaps they will inhabit artificial worlds. Perhaps they will have changed biologically or technologically. Perhaps the descendants of humanity will look back at the year 1977 as we look back at the earliest chapters of human history. Or perhaps humanity will not survive that long. Science cannot tell us which of these futures will happen, and that uncertainty is important. The purpose of imagining 1 billion years is not to predict the fate of humanity. It is to understand the extraordinary difference between the lifespan of a civilization and the lifespan of the cosmos. Voyager makes that difference tangible, because even if every human voice associated with its launch has disappeared, the spacecraft could still be there. Its electrical systems would almost certainly have been silent for an immense length of time. Its scientific mission would be nothing more than history. But its physical journey could continue, slowly, quietly, without needing anyone to tell it where to go. By then, radiation and tiny particles of dust would have had countless opportunities to interact with its surfaces. Materials would have aged. Some components might have deteriorated severely. Others could remain recognizable. We cannot know exactly what Voyager would look like after 1 billion years, but perhaps it would no longer resemble a functioning machine at all. It might be a darkened, weathered object moving through interstellar space, a relic, a fragment of a particular moment in Earth's history. And yet, somewhere on that relic would be something even more remarkable: the golden record, a small golden message attached to a spacecraft that no longer has the ability to speak. It carries sounds from Earth, images, music, greetings, a record of life, a record of a civilization trying, in its own modest way, to introduce itself to a universe it barely understood. And now imagine that message surviving into a future where the Earth of 1977 is unimaginably ancient. The continents have changed, the species have changed, the sun has grown brighter, the solar system has traveled around the Milky Way again and again, and Voyager continues outward. Perhaps no one is listening, perhaps no one ever will, but the message remains. That is where the journey begins, to change from a story about distance into a story about memory. Because after 1 billion years, the most remarkable thing about Voyager may no longer be how far it has traveled. It may be the fact that something from Earth is still carrying the evidence that we were once here. Long after Voyager has fallen silent, something aboard it may still be speaking, not through radio waves, not through a computer, not through a signal traveling back toward Earth. Instead, the message would be something much quieter, a physical object, a small golden record attached to the spacecraft, carrying sounds, images, music, and greetings from Earth. The golden record was created with an unusual question in mind. If another civilization, somewhere in the distant future, were to discover Voyager, could it understand that the object had come from an inhabited world? Could it somehow recognize that the machine had been built by intelligent beings? And could it learn something about the people who sent it? The answer was never guaranteed. In fact, the chances of anyone finding Voyager are extraordinarily small, but the possibility was enough to make the record worthwhile. The spacecraft itself is tiny compared with the distances between stars. Even if another civilization eventually existed in the same broad region of the galaxy, Voyager would be only a small object drifting through an enormous ocean of space. Imagine dropping a single grain of sand into a vast forest and asking whether someone might find it millions of years later. The forest is enormous. The grain is tiny, and there is no sign pointing toward it. That is roughly the scale of the problem. Even passing through another star system would not automatically mean that Voyager would be discovered. A star system can contain planets, moons, asteroids, dust, and enormous amounts of empty space. Voyager could pass through the region and simply continue onward, unnoticed. No civilization might ever see it. No telescope might ever detect it. No spacecraft might ever approach it. The galaxy is simply too large. And yet, the golden record exists because science does not require certainty before asking an interesting question. It is a message placed into the future, a small attempt by one species to introduce itself to the unknown. The record contains sounds from Earth. There are natural sounds. There are human voices. There are greetings in many languages. There is music. There are images representing aspects of human life and the world from which Voyager came. Together, these pieces form something more than a collection of information. They form a portrait, not a perfect portrait, not a complete history of humanity, just a small selection, a glimpse, a way of saying, this is what our world sounded like. This is what some of us looked like. This is how we imagined ourselves. This is the planet we called home. And perhaps the most fascinating thing about the record is that it does not depend on Voyager's electronics in the same way its scientific mission did. The spacecraft's instruments need electricity. Its transmitter needs electricity. Its computer systems need electricity. But a physical record can simply remain where it is. It does not need batteries. It does not need software. It does not need a communication antenna. If the record remains physically intact, the information engraved into it could potentially survive long after Voyager's technological systems have become useless. The source material emphasizes this distinction. Voyager's electrical systems are expected to fade, while its physical structure may endure much longer. Its metal surfaces can be gradually marked by microscopic impacts and radiation, but the space between stars is so empty that a major collision remains extremely unlikely. The record itself was designed with durability in mind. Its outer surface is protected, and its construction was intended to endure the harsh environment of interstellar space. That does not mean it will remain perfectly untouched for billions of years. Nothing physical comes with such a guarantee. Radiation can alter materials. Tiny particles can strike surfaces. Time can slowly change almost anything. But compared with the fragile technology that allows Voyager to communicate, a physical object can have an extraordinarily long afterlife, and that creates a strange possibility. Imagine a future civilization discovering Voyager long after Earth has become unrecognizable. Perhaps they would first notice the spacecraft as an unusual piece of metal. They might not know what it was. They might not know where it came from. They might not even know that it was artificial. But eventually, they might examine it more carefully. They could discover the golden record, and then the spacecraft would become something different. It would become evidence. Evidence that somewhere, sometime, another technological civilization existed. A civilization that had built machines. A civilization that had learned to leave its planet. A civilization that had looked into the darkness and wondered whether anyone else was there. The record could become something like an archaeological artifact. Think about how archaeologists today feel when they uncover an object made by people who lived thousands of years ago. The object may be small, it may be broken, it may be difficult to interpret, but it tells us that someone was there, a hand shaped this, a mind designed this, a community used this, a life existed behind the object. The golden record could play a similar role on a cosmic scale. Except the distance between the maker and the discoverer could be unimaginably greater. The civilization that discovers it might exist millions of years after Voyager was launched. Humanity itself might have changed beyond recognition. Perhaps Earth would still contain life. Perhaps humans would live elsewhere. Perhaps no one would remain who remembered the civilization of the 20th and 21st centuries. And yet, the record could still carry a tiny fragment of our existence forward. There is something beautifully fragile about that idea. The message was never guaranteed to be received. It was not sent toward a known recipient. There was no address, no planet marked on a cosmic envelope, no promise that anyone would answer. It was more like leaving a small bottle in an ocean whose waves stretch across the galaxy. Perhaps it will never be opened. Perhaps it will drift forever. But someone, somewhere, could theoretically find it, and if they did, the meaning of Voyager would change again. It would no longer be merely an old spacecraft. It would be a fossil, a metallic fossil of a civilization that once stood on a small planet around an ordinary star. A civilization that had only just begun to understand how enormous its universe really was. And perhaps the most moving part is that Voyager does not need to be discovered for the record to matter. The act of creating it already tells us something about ourselves. We knew we were small. We knew the universe was vast. We knew the chances of being found were tiny. And still, we placed a message on a spacecraft and sent it outward, not because we knew someone was listening, but because, for a brief moment in human history, we wanted to say hello. And now that hello is traveling onward, quietly, patiently, across the darkness. There is a quiet difference between something being alive and something simply continuing. A living thing must constantly maintain itself. It needs energy. It repairs damage. It responds to its surroundings. A spacecraft is different. Once Voyager's active systems have finally fallen silent, the machine will no longer need to perform its mission. It will not need to wake. It will not need to sleep. It will not need to decide where to go. It can simply continue. And if Voyager avoids a major collision, there is no obvious reason why its physical journey must end after 1 billion years. The spacecraft could drift for billions of years more. By then, almost everything that makes Voyager familiar to us could have become ancient history. The engineers who built it would be gone. The scientists who studied its discoveries would be gone. The computers that once received its signals would be relics themselves. Even the institutions responsible for the mission might exist only in historical records, and yet the spacecraft could still be somewhere in the Milky Way. Not alive, not conscious, not observing, just moving. The galaxy would continue its own enormous dance around it. Stars would be born. Stars would die. New planetary systems could form. Other worlds could be transformed by impacts, geological activity, atmospheric changes, and the slow passage of time. Voyager would be a tiny witness to none of this in the human sense. It would not understand what it passed, but it would pass through it. And eventually, the Milky Way itself would experience one of the most dramatic changes in its future. Far away, another large galaxy is approaching, Andromeda. The Milky Way and Andromeda are moving toward one another under gravity. Over a timescale of billions of years, their interaction is expected to profoundly reshape both galaxies. This is sometimes described as a collision, but it is important to imagine it correctly. Galaxies are not solid objects. They are enormous collections of stars separated by vast amounts of space. So when galaxies interact, it does not mean that every star crashes into another star. In fact, direct stellar collisions are expected to be extremely rare. Instead, gravity gradually rearranges the enormous structures. Stellar orbits can change. Gas clouds can be disturbed. The shapes of the galaxies can become distorted. Over time, the the two systems can merge into a new galactic structure. And somewhere within this enormous transformation, Voyager may still be drifting. It could be carried through a galaxy whose appearance has changed almost beyond recognition. The Milky Way of the future may not resemble the spiral galaxy we picture today. Its stars may occupy different paths. Its structure may be different. The Sun itself may be located in a very different region of the resulting galactic system. And Voyager may simply continue. This is another reason why the exact future location of the spacecraft cannot be described with certainty. On the scale of billions of years, gravity becomes part of a much larger story. Small changes accumulate, stars move, galaxies interact, orbital paths evolve. The spacecraft's future becomes less like a carefully drawn line and more like a broad journey through an ever-changing ocean. But even if we cannot know exactly where Voyager will be, we can still understand what it represents. That may be more important than its final coordinates. Voyager is physical evidence that a civilization on Earth once developed the ability to build machines capable of crossing the boundary between its planetary home and interstellar space. That is extraordinary. Humanity did not merely look at the stars. For the first time, we sent something from our planet into the space between them, and we sent it carrying a message. The spacecraft, therefore, has two lives. The first is technological. It was a scientific instrument. It had computers. It had sensors. It had a transmitter. It followed a carefully designed mission. The second life is much longer. The life of an artifact. Once the technology becomes silent, Voyager may still remain as a physical object traveling through the galaxy. In that sense, it begins to resemble something archaeologists discover on Earth. A piece of pottery, a carved stone, a tool made by hands that disappeared long ago. The object itself cannot explain who made it, but its existence tells us that someone did. Voyager could someday play a similar role on a cosmic scale. Imagine for a moment a civilization discovering it in a distant future. They might know nothing about 1977. They might know nothing about Earth as we know it. They might not even recognize the language on the golden record. But they could see that the object was engineered. They could study its materials. They could examine its unusual structure. And perhaps they would discover the record. Then they would have something more than an unidentified machine. They would have a clue. A civilization once existed. It lived on a planet orbiting a star. It developed technology. It wondered about the universe. And it sent a message outward. Whether anyone ever finds Voyager is impossible to know. The probability is extraordinarily small. But the possibility does not need to be large for the idea to be meaningful. Because Voyager was never really about guaranteeing that someone would discover us. It was about reaching beyond the boundary of what was familiar. When it launched, the spacecraft carried the hopes and curiosity of people who knew they were sending a tiny object into an almost incomprehensibly large universe. They could not know where it would eventually travel. They could not know what worlds might exist in its future. They could not know whether another intelligence would ever encounter it, but they sent it anyway. And perhaps that is the deepest meaning of Voyager. Not distance, not speed, not even survival. It is continuity. A thought created on Earth becomes an object. The object becomes a spacecraft. The spacecraft becomes an interstellar traveler. The traveler eventually becomes silent, and the silent object continues. Long after the voices disappear, the journey remains. Long after the original mission ends, the path remains. Long after the people who built Voyager have become part of Earth's history, something they made may still be moving through the galaxy. 1 billion years is almost unimaginably long to you, but on the scale of the cosmos, it is only a small portion of the story. The universe has existed for billions of years. Stars live and die across immense stretches of time. Galaxies change, worlds appear and disappear, and Voyager becomes one tiny thread woven into that enormous fabric. Perhaps someday its metal will be damaged beyond recognition. Perhaps the golden record will eventually become unreadable. Perhaps Voyager will travel forever without encountering another civilization. We do not know. And perhaps we do not need to know. For now, you can simply imagine that small spacecraft continuing outward, the sun growing more distant behind it, the stars slowly changing position, the Milky Way turning, the galaxies moving, and Voyager carrying its tiny message from Earth, drifting quietly through it all. There is something peaceful about that image, a machine no longer asking anything from its creators, no longer waiting for instructions, no longer required to arrive anywhere, just moving. And perhaps, in that silence, Voyager becomes a reminder of something very human, that even though our lives are brief, we have always tried to leave traces of ourselves behind. A drawing on a wall, a name carved into stone, a photograph, a story, a message sent into the darkness. Voyager is simply one of the farthest examples. A small piece of Earth traveling farther than any human being has ever traveled. And somewhere, far beyond the edge of our familiar solar system, it continues, quietly, patiently, carrying the memory of a world that once looked up at the stars and wondered what might be waiting beyond them. And now, as you let that image settle, you can return for a moment to the small blue planet from which the journey began. The Earth is still here, the sun is still shining, the stars are still moving, and Voyager is still drifting. For us, 1 billion years feels almost like eternity. For the universe, it is simply another passage of time. Perhaps that is the gentlest lesson of all. We do not have to last forever to become part of something larger than ourselves. Sometimes, it is enough to make something carefully, send it outward, and let it carry a small piece of our story farther than we ever could. So if you are resting now, you can let the journey grow quiet. You can imagine Voyager becoming a tiny point of metal among the stars, its instruments silent, its transmitter quiet, its golden record waiting patiently in the darkness. There may never be another listener. There may never be another hand to hold it, but it is there, a small reminder that once, on a planet orbiting an ordinary star, a species looked outward and wondered. And perhaps that is enough. The spacecraft continues into the darkness, the galaxy continues turning, the stars continue moving, and somewhere in that vastness, a little machine from Earth keeps drifting onward. Good night, and wherever you are tonight, may your own journey toward rest be gentle and peaceful.